Hello everyone and welcome to this second problem of general force system. Now in this problem the force acting on a 1 meter length of a dam, so you can see that this construction given is of dam and that is of 1 meter length, so that is dimension which is perpendicular to this paper is given as 1 meter, but there is no use of that dimension. It is shown in figure. So you can see that force number 1, 2 and 3, in total 3 forces are acting on the dam. Determine the resultant force acting on the dam. Calculate the point of intersection of the resultant with respect to base. So let us first figure out what we have to find. So determine the resultant force. That means I have to calculate R, and second I have to calculate theta. So that is I have calculated what? Resultant force. Moreover, I have to calculate the point of intersection of the resultant with the base. So just randomly assume that this is resultant force R and say resultant force is acting over here. So this is force R. Then I have to find this intersection point either with respect to point D or with respect to point S. So I have to find basically this length. So to this length we call it as what? X intercept, and hence I have to find what? X, that is X. In short, for given sum I have to find magnitude of the resultant, direction of the resultant and the location, but location is what? X intercept, because it is given that I have to find the point of intersection of the base with the base. Since base is horizontal, I have to find X component. Now step number 1 is to resolve the forces along X component, along X and Y component, that is along X direction and Y direction. Let us start with this force. We'll call this as F1. Since that is a horizontal force, no need to resolve this. Next is, say this is force F2, 100 Newton, it's vertically downward force, so again no need to resolve it. When we are going for third force, you can see this, that is a 30 kilonewton of force that is acting at some angle with respect to, we can say, either horizontal or vertical, and to that force I have to resolve. But for that first I have to find angle theta. So now if I resolve this force, then this will become X component and this will become Y component. This force is physically acting in third quadrant, so its X component will be towards left hand side and Y component will be downward. Now here you can see that this inclined surface is making angle 60 degree with horizontal. When this is making angle 60 degree with horizontal and its force is perpendicular to that surface, and force is what? Perpendicular to that surface. So that force will make same 60 degrees with vertical. Okay, so here in simple words can we say that this force is 60? Okay, this in simple words can we say that this angle is 60? When this is 60, here you can see that if I complete this triangle, this will be how much? 30. When this is 30, this is 90, then this will be what? 60. Okay, when angle is 60, you can see that angle is given with respect to the vertical component, then that vertical component will become cos and horizontal component will become sine. Force is of 30 kilonewton, then can I say this is 30 cos 60, this is 30 sine 60. With this I have resolved the forces along X and Y component. Now we will go for step number 2, and here I have to calculate the summation of all the component along X axis with sign convention shown over here, that is forces that are acting on right hand side are positive and left hand side are negative. So let us start with all the horizontal forces. So first will be F1. You can see F1, 50 Newton of force is acting on the right hand side, so here I have taken it as positive. Second is this 30 cos 30. So you can see that this 30 cos 30 is acting on the left hand side. Here you can see this 30 cos 30 is acting on the left hand side. Hence I have put minus. On solving this equation, I'll get answer as 24.02 kilonewton. Since I'm getting answer as positive, direction of summation of Fx is on the right hand side. Next we will go for summation of Fy. So to calculate the summation of all the component acting along y axis, for this I'll consider sign convention as upward forces are positive and downward forces will consider as negative. So let us start with vertical forces. Very first force is F2, that is 120. Since it's acting in downward direction, I'll say minus 120. And next is 30 cos 60. Again it's in downward direction, so minus 30 cos 60. On solving this, I'll get summation of Fy as minus 135 kilonewton. That is 135 kilonewton acting in downward direction. Next we will go for magnitude of the resultant force. So R is equal to summation of Fx square plus summation of Fy square and then under root of the answer. By solving this, I have to put value of Fx, so I'll say under root of Fx, so 24.02 ka square plus Fy is 135 square. Okay, and on solving this, I'll get answer of R, that is resultant, as 137.12 kilonewton. So I have got magnitude of the resultant. Next we will go for direction of the resultant. So we have to find angle theta. Okay, so formula for angle theta is what? Tan inverse of summation of Fy by Fx. Remember, for this we will consider Fy and Fx only positive value. When we'll put this value, so Fy you can see it's 135 and Fx we know it's 24.02. On solving this, that is tan inverse of 135 by 24.02 will give you answer as 79.91 degrees. So resultant is acting at 79.91 degrees. Now let us locate this resultant. So to locate this resultant, first we will draw this x-axis and then y-axis. Now what answer you are getting for summation of Fx? You can see you are getting positive answer. Okay, so your summation of Fx is acting on the right hand side. So this is summation of Fx, whereas summation of Fy you are getting as negative, so it's acting in downward direction. So this you are getting as summation of Fy, and that answer you are getting as what? Negative. That indicates that your resultant lies in the fourth quadrant. So here I'll say this is resultant R making angle theta with respect to summation of Fx, that is we can say x-axis. Okay, now with this we will go for next, that is location of the resultant. Now to find the location of the resultant, we have to first find summation of moment. Now here very important thing is that we can calculate moment either about point O or we can calculate about point D. See, this is point O and then this is point D, okay, as given over here. But important thing is, for with whatever point we are calculating moment, we must know distance of force from that particular point. That will make my calculation easier. Say for example, when I'm calculating moment about point O, say this is a force, this F3 force goes here, then I have to find this distance, that is perpendicular distance. But when I'm calculating moment about point D, you can see that its perpendicular distance 1.25 meter is already given. So that will make my calculation simple. So rather than going for point O and by making some more difficult, we can make it simple and we can go for point D. So now we will prefer D as a reference point, since the calculation of moment about point D is the most convenient in simple language because distance is given to you. Okay, so we'll go for summation of M into D. Now for summation of M into D, we have to find this moment about 1, 2 and 3 forces. Let us start with F1. So F1 is given as how much? 50. So here I'll write in bracket 50 into what is the distance? Another perpendicular distance. Force is horizontal, then its perpendicular distance will be what? Vertical. So vertical distance between force and point D is given to me as how much? 2 meters. So 650 into 2, and you can see that it will create moment. As you can see here, it will create moment in which direction? It will create moment in clockwise direction. So for that I'll put here negative sign. So that is 50 into 2 and then minus. Next you can see is this 120 Newton. So here I can see downward force 120. First I'll write 120 multiply by, okay. Next is, since the force is vertical, I have to find this horizontal distance between force and the point D. Okay, now total distance is given to me as 6 meters and this remaining distance is 2 meters. Then what will be this distance? That will be 6 minus 2 will give me this required distance, and that is how much? 4 meters. So here I write 120 into 4. Next we will have to check its direction. Then here you can see that this will create moment in anti-clockwise direction. So for that we have put positive sign. Next we will go for this inclined force. Now one more important thing, we will not go for its component. Okay, why in previous sum we were calculating moment for each component? Because we were not knowing perpendicular direction of that inclined force. But in this case you know that this inclined force is at the given distance 1.25 meters with respect to point D. So directly a perpendicular distance is given to you, so no need to resolve it and calculate moment for individual component. We can directly go for 30 Newton of force, and this 30 into its perpendicular distance with respect to D is given as what? 1.25 meters. So here I can directly say it's 30 into 1.25, and you can see that force is again creating moment in anti-clockwise direction. So I have put positive sign over here. By solving this, I'll get summation of moment about point D as positive 417.5 kilonewton meter. That is 417.5 kilonewton meter in anti-clockwise direction. Positive sign indicates what? Anti-clockwise direction. Now, as explained last time, that Varignin's theorem can be used in 3 different ways. First, I can say that summation of moment about any point, since in this case we are taking D, will take same. Summation of moment about D is equal to R into D. So what is D? D is a perpendicular distance. Okay. Next, summation of moment about D can be equal to, suppose I want X intercept. Okay, then since this is a perpendicular distance, what is perpendicular to X? That is Y. Then I say summation of Fy. And in third way, summation of Fd, similarly I can get summation of Fx into Y. So remember, here I am getting perpendicular distance of that inclined resultant, okay, because resultant is inclined at 79.19 degrees. Here I will get X intercept and here I will get Y intercept. So looking at question, what they are asking X intercept, because they are asking that we have to calculate the point of intersection of the resultant with the base. Since base is a horizontal, we are calculating what? X intercept. Then applying this formula, summation of MD is equal to summation of Fy into X, and by putting this value, summation of MD is what? 417.5 and Fy is what? 135. On solving this, we will get answer as 3.092 meters. So since MD is in anti-clockwise and R is directed towards the fourth quadrant as shown in the point, when the resultant intersect the base this to the left hand side of the point D. So now let us see that how we are getting this formula in terms of plus and minus sign. Okay, so say this is a construction of dam, and you can see that this resultant force is inclined like this. I'll copy paste it over here. So let us say this is a resultant force R, and that is making angle theta with x-axis. Okay, so what we have to find? Basically we have to find this x component. ये x component मुझे find करना है, right? Okay, so for this I have to first find what is the moment produced by this r? Okay, so this r is producing moment in what direction? Anti-clockwise, and that is why here I have considered summation of fy into x as positive. Suppose यहाँ पे r clockwise moment produce करता, तो suppose मैंने o के about moment लिया रहता, तो ये r into this, now this time this will become x, तो मुझे यहाँ पे minus sign लेना पड़ता, so minus of fy into x. So here what I have assumed, that this distance 3.092 is on the left hand side of the point D, where left hand side, see x is assumed on the left hand side of the point D, and I'm getting answer as positive. When I'm getting answer as positive, my assumption is right, and this x is equal to what? 3.092 meters. Okay, so in this sum, first we have calculated x components, y components, then resultant, then theta, and then finally we have located resultant along its x-axis, so where that resultant intersects to the base. I hope you have understood this sum. Thank you.